So this next one, let's go ahead and do integral of x plus 11 over x squared plus 2x minus 3. Okay. So you notice the big difference on this one is it's not 1 on the top here. Okay, so it's going to be, a little different, but still follow the same basic rules. So again, I'll do all my partial fraction work over here, and then when I find something that's equivalent to this, but just looks different, is easier to integrate, I'll put it back in. Alright, so the first step's the same. I'm going to factor out the bottom. And now when I write this over here, it's not going to be 1 over with the factored version of the bottom. It's going to be x plus 11 over the factored version of the bottom. So in this case, it's going to be x plus 3x minus 1. Make sure that looks right. That looks correct, yeah. And then that's going to be equal to, and then again, I want to split this up into two different fractions, one with this denominator, one with that denominator. I'll put a over x plus 3 plus b over x minus 1. And now I use the same series of steps that I just did a second ago. Usually I'm not going to actually write out, the x plus 3x minus 1 here, write it out over here. You can if you want to. So if you want to go through and put this in parentheses and write that out each time, if that helps you, do that. Whatever benefits you, go ahead and do that, okay? I'll just kind of think, okay, I'm going to multiply both sides by x plus 3 times x minus 1. So on this side, of course, it's just going to cancel out the bottom and leave me with x plus 11. On the right side, when I multiply times this, when I multiply this times my first term, my x plus 3's will cancel, which will just leave me with a times x minus 1. When I multiply this times my second term, my x minus 1's will cancel, leave me with b times x plus 3. Okay, so at this point here, I'm just going to, kind of go a little quicker and try and simplify and combine like terms over here. So we'll start by distributing out x minus a plus bx plus 3b. Combine my like terms, get my x's together. X plus bx minus a plus 3b. Factor my x out. Alright, so now I'm at a point where I can use that idea of these, the left and the right side being equal. Now in this case we have to make sure we're very careful, so I notice I have an x here, so on the right side, the thing in front of an x is a plus b. And it's not always going to be that. You could have, something that has to, if you had something else in front of your x squared, like a 2, you might have a 2 for one of those things. But I just want to make sure it's not always necessary, it has to be a plus b there. On the left-hand side, I notice I actually have an x here this time, unlike last time. So last time I just, put a 0x in there, but this time I already have an x, so this coefficient is 1, essentially. Okay? So, I have to make sure that both my coefficients are the same, so that means a plus b should be equal to 1. And my constant terms, in this case 11, and negative a plus 3b, those have to be equal as well. The constant terms have to match up. So I have negative a plus 3b is equal to 11. Got my two equations, got my two unknowns. I'm going to go ahead and I'm going to use substitution again. So I'll subtract b, and I'll get a is equal to 1 minus b. So I just subtracted b to solve for a. Go ahead now and insert 1 minus b in where I see a into this equation. So it's going to be negative a, instead of negative a, I'm going to write 1 minus b plus 3b equals 11. At this point here, I'm going to go ahead and distribute my negatives. So I have negative 1 plus b plus 3b equals 11. So now I'm just solving for b. And I'm going to get, let's see here, negative 1 plus 4b equals 11. Add 1 to both sides. 4b equals 12. So therefore b is going to be equal to 3. Okay, so b is going to be equal to 3. To find out what a is, I can just go ahead and put that back up here. I'll put 3 in for b, so I have a is equal to 1 minus 3. So that means a is equal to negative 2. So what I'm going to do, I'm going to take negative 2, plug it in here where I see a, take 3 and plug it in here where I see b. Alright, so I'm going to replace that over here. So instead of writing it like this, right, the thing that I'm going to replace is the exact same thing. It's equivalent, it's equal. but it just looks different. It's going to be easier to integrate. So if you go through and you actually found a common denominator and simplified things, it would go back exactly to this. Okay? So when I do my integrals here, I'm going to go ahead and, to make it easier for myself, I'm going to factor a -2 out and a 3 out. So to write it like this, I can bring constants outside of my integrals. I guess I should have a dx here as well. And then I'm going to do antiderivatives. They both follow the natural log rule, since the derivative at the top equals the bottom, so it'll be -2, natural log absolute value of ln x, -2 natural log absolute value of x plus 3, plus 3 to the natural log absolute value of x minus 1, plus c. In this case, there's no simplifying that can be done using natural log rules because of the different coefficients in front. So the coefficients in front have to be the same in order to use that natural log rule to simplify.